Okay, trigonometric equations. So different to identities, whereas identities are saying one thing is equal to the other thing no matter what. A trig equation has specific restrictions applied to it. And what we're going to be doing is we're actually going to be looking at how to solve these trig equations. So before we start solving trig equations, it is important that we keep the following in consideration. So we're always going to pay attention to the domain in which the angle can lie. So if it's between 0 and 180 degrees or 360 degrees, something like that. And the other thing we're going to take into consideration is if the solutions are boundary angles, read solutions of a sketch of the graph. So we're going to be looking at the sketch of the graph in some of the cases. Not all of them, but some of them. We won't actually do an example on that because it's quite easy. All it is just a matter of drawing a graph and checking where it is. Okay, so remembering that a cos graph looks like this, and a sine graph looks like this. Which domain to? And then doing your tan, cotan, secant, all that jazz. Okay, so the method for solving trigonometric equations. Step 1. Okay, draw a quadrant diagram. Okay, so we're going to do this and then draw a ray in each. So this part, draw rays, and then draw a ray in each of the in each of the quadrant it could be in. Okay, so if you're dealing with a positive one, then you're only going to be putting them in the positives ones. If you're only dealing with negative ones, then you're only going to be dealing with the negative ones. It's really important you draw that, otherwise you might put in too many answers or not enough. Okay, so step 2 is find related acute angles. Okay, makes it much easier if you've got that diagram. So, if you've got the diagram, you're doing 30 degrees. Okay, I'm drawing in all my rays that it could be. Okay, so I know that's 30, that's 150. That's 210, and that's 330, okay? So just keep in mind that doing the rays is going to help you with that second step, okay? And just work with... So what we're going to do, even though if we do have negative numbers, okay, we're going to treat them as if they were positive anyway, but then just apply the negative in it. Because if we're doing one that we don't know the special angle of, or the exact value of, we're going to have to use our calculator to approximate, and we can't really put a negative number into our calculator and for it to reliably work. Okay, and then mark the angles at the... Oh, this is step 3. So then mark the angles. Okay, mark the angles at the end of the rays, just to keep in mind what you've got, and then write a conclusion. Okay, so actually answer your question. So what we're going to do is we're going to do some examples of these. Okay, we're only going to start off with this type of one, and then we're going to talk about a so for this video we're just going to do this one example, and then in the next one we'll talk about some different types of equations we can have. Okay, so these ones are pretty... actually, no, you know what? We're going to keep going and to put both these videos into one. The other thing that we just need to talk about before we keep going is just to be mindful that we might have more than one ratio in our equation. So if there are more than one ratios, so if there are more than one ratios, or ratio, I don't know how you say that, then we want to turn one of them into the other. And we're going to do that using identities. Okay, so we're going to do that by using some identities. So Pythagorean identity, our ratio identities, which will come up quite a bit, something along those lines, okay? So let's have a look at some examples on how to do this. Now, solve each equation for 0 degrees, for x between 0 and 180 degrees. Okay, so that is, we're only focusing on the top half of our diagram. Okay? So, what we're going to do in part A before we actually do anything else is we're actually going to simplify this a bit. Because looking at that, that looks disgusting. Okay? Like, how on earth am I meant to solve this? Well, we can start off by doing something that's quite nice, and just by, solving or rearranging for an for sine. So, if I subtract 2 sine x from both sides, so minus 2 sine x minus 2 sine x, we get 3 is equal to 3 sine x. Okay? And then by doing that, okay, what we've got then is if we divide both sides by 3, we get 1 is equal to sine x. And this is actually one of our boundary angles. So it turns out we are actually going to be doing a boundary angles. So when sine x is equal to 1, it's either on the 0 degrees, 90, 180, 270, 360. Okay? So what we're going to do in this case is we're actually going to quickly sketch a picture of sine. Now we know at 0 degrees, our sine is 0. At 90 degrees, our sine shoots up to 1. 180, we shoot down to 0. At 270, we go down to -1. And then at 360, we go back to 0. Now, we're only concerned about the values between 0 and 180. Okay, so my line, I'm going to stop it there, and I don't actually need anything else, so I'm done with that. Now, what I'm going to do is I'm going to just quickly sketch what sine looks like, but do it properly. And it looks something like that, but, again, drawn properly. Okay, next one's going to be the last one. Yeah, I'll do. Okay, and so we're looking for the values where sine is 1. And so where is it 1? And it's 1 at 90 degrees. So sine of x is equal to 1, so x must be equal to 90 degrees, okay? For that equation to be true, because the only place where sine is equal to 1 is between 0 and 180 degrees, is when x is equal to 90, or when sine is 90 degrees. Okay. Now we're going to do part B. So part B is sine of x is equal to 2 cos of x. Now I'm just rewriting that so I know it's there, and so that I can scroll down a bit more. So, like I said before, if we've got the same amount, so if we've got different ratios, then we want to usually apply a trigonometric identity to produce an equation in only one trig function, okay? So what I'm going to do in this case is I'm actually going to just divide both sides by cos of x. So divide by cos of x and divide by cos of x. Okay, so what happens when we do this is, well, the cos of x cancel on the right-hand side, but we remember that sine of x, should do is right, sine of x is equal to cos of x, and that's what we've got left on the left-hand side. Now, we know that, or we remember that sine of x divided by cos of x, well, that's just equal to, using our trig ratio identity, sine of x divided by cos of x is just equal to tan of x. And tan of x is equal to 2. Now, what are some things that we know about this? Well, we know that tan x is equal to 2, so tan must be positive, okay? So if I quickly sketch my quadrant, I've got my first, which is all, stations, to central. Now we know tan is positive in the first, so there's a ray in the first quadrant, and the third quadrant. However, my restriction on x is that it's between 0 and 180 degrees. So that means that I'm only looking at the values in the first two quadrants. So this second tan I don't actually care about at all because it's not within the restrictions that I've been given. So now it comes down to the fact that, well, how do I work out what this value is? I've got tan of x is equal to 2. Well, one of the ways is to literally just use your calculator. If we've got tan of x is equal to 2, then we know that x must be equal to the tan inverse of 2. And so x must be equal to, put it into your calculator, press the degrees, minutes, and seconds because we're trying to find an angle in this case because it's x, because we're trying to find tan of what angle is equal to 2. And you'll get approximately 63 degrees and 26 minutes for that one. Okay. So those are two of the more easier types of ones. So start off by just, rearranging your trig equation until you've got something that you can actually work with, okay? Once you've got that, draw a picture of all the information that you're given, omit anything that you don't want, and then try and solve, okay? So if it was between 360 and, 0 and 360 instead, so if, you know, this restriction up here actually said 360 degrees, then what we would do is we would then include that angle there. After we worked out the acute angle, well, we know that that angle in there is the same as well. Okay, so that's also 63 degrees and 26 minutes, say, using the acute, or just the related acute angle. And then so this one would also be equal to 180 degrees plus 63 degrees 26, okay? So that's how you would do that one. But we don't need it for this one because we're only concerned about the first two quadrants, and so that is our answer and our only answer. Okay, so we're going to have a look at two more really quickly. Okay, so example number 2, solve each equation for between 0 degrees and 360 degrees this time. So a little bit different in this regards, and we're going to start off with sec squared x is equal to 2. Okay, so this one is a bit harder. So let's start off by, well, I'm going to start off by rewriting the equation down, and we're going to start off by doing some stuff that we know. Now, because if we've got a value we don't know how to evaluate, so like, you know, cos of 75 degrees, like, I don't know how to do that, okay? Unless I've got a calculator, which will give me an approximation. So what we're going to do instead is we're going to rearrange this equation around a bit until I've got something that we want. And we know that if I've got an angle that I don't know off the top of my head, it's not an exact value, we're going to use our calculator to do it. But you'll notice on your calculator, you can't actually put sec squared or sec into your calculator. So what we're going to have to do is we're going to have to use the actual, definition of sec squared, which is 1 over cos squared of x, and that's equal to 2. Now what we're going to do is, well, I've got 1 over cos squared x is equal to 2. That seems too hard. What I'm going to do is I'm going to take a reciprocal of both sides. And that way I'm going to get cos squared of x on the top, and I'm going to get a half, on the left, and get a half on the right. Now, I don't know much about cos squared x, but what I do know about is cos x. So what I'm going to do is I'm going to take a square root of both sides, and that's going to give me cos x is equal to square root of 1, well, that's just 1 over the square root of 2, which is equal to root 2 on 2. Okay, so when is cos x equal to that? Okay, well, now we've got something that we know how to deal with. So cos of x is equal to root 2 on 2. Okay, so cos x is positive. Let's now draw a picture of what this might look like. So starting off with my quadrant diagram. Okay, cos is, in this case, positive. Cos x is equal to a positive number. So all stations to Coaldale. And in this case, my ray could either be here or it could be here, in the positive areas where cosine is positive. So because cos of x is positive, so it's equal to a positive value, my ray could be either in A or in C. So what we're going to do is we're going to find the related acute angle now, okay, so that we can work out what both of them are equal to. So cos x is equal to root 2 on 2. When is cos x equal to root 2 on 2? I hope you remember when it's equal to root 2 on 2. So x must be equal to 45 degrees. So that's equal to 45 degrees in there. And this one is also equal to 45 degrees in there. Okay, so my ray is sitting at 45 degrees in this one. But over here, it's 360 minus 45 degrees. Or in other words, this one here is equal to 315 degrees. Okay, so the two values in this case that x could give, so that it would give a value of root 2 on 2, is cos is equal to cos of 45 or cos of 315. So basically what we're trying to do is say, what value needs to go into here to give me this answer? And in this case, it is 45 degrees or 315 degrees, if we're restricting it between 0 and 315. Okay? So with that being said, if we were to restrict the domain, so it was only between 0 and 180 degrees, we wouldn't include this value here. But because now that we do have that range between 0 and, that domain between 0 and 360, we do include the 315. If my range was between 0 and 720, well, we would then have to do a full revolution plus a bit extra. So 330 plus 45, and then 330 plus 315. And that would give me my next two, okay? And alternatively, if we did negatives, then we have to go in the counterclockwise way, okay? So that was A. Let's have a go at B now. B says 2 sine of x, and I've actually got it written down next to me, so I'll have a look at that one, minus tan of x is equal to 0. Okay, so deceptively, let's have a look and see how we can solve this one. So looking at this, I might start off by moving the tan to the right-hand side. So we're going to get 2 sine of x is equal to tan of x. Okay, well, I've got some sines and I can't do too much with that, but I also have a tan. And we know that tan, using our identity, is just the same as sine of x over cos of x, okay? So tan of x is equal to sine of x over cos of x using that trigonometric identity. Then I'm going to get rid of this sine on the left-hand side, okay? So I'm going to divide by sine of x to leave the 2 there, divide by sine of x to leave the 2 there, and what we get is we get that 2 is equal to, well, so that cancels with that, sine of x divided by sine of x, that cancels with that, and I'm left with 1 over cos of x. Or in other words, well, actually, let's leave it at that for now, because we don't want to change it to what it is, which is sec, because we can't put sec into a calculator. But what we can put into a calculator is cos. So if 2 is equal to 1 over cos, or 1 over cos of x is equal to 2, how can I get the cos of x by itself? Okay, and I'm hoping that you say to yourself, well, let's do the reciprocal, or we could multiply by cos of x and divide by 2. So doing the reciprocal is the quicker way. Removes the 1, makes this over a half, or equal to a half. So now it becomes, well, when is cos of x equal to a half? Now we've got this statement here, we're going to draw our picture. Now, so cos of x is equal to a half, positive. So we're drawing in our rays where cosine is positive. So that is in the first and fourth quadrant. And what we're asking is, well, what's the angle from here to here? Which is the same as that one there, to give us what that ray is, or where that ray is pointing. So remembering this time, again, it is between 0 and 360 degrees. So anything can be used. So for this one, when is cos of x equal to a half? I'm hoping that you guys remember that that is when it is equal to 60 degrees. So that angle in there is 60 degrees. So that also means that this angle in here is 60 degrees here, okay? So that means that that ray there is 60 degrees, and that ray in here is 300 degrees, because it is 360 minus 60. So cos of x is equal to half whenever x is equal to 60 degrees or 300 degrees, okay? And you can check in your calculator and do that too. Let's say that instead of being equal to a half, it was actually equal to a negative a half. Okay, so if you actually had a negative value, you'd still have to work out this 60 degrees here, because when cos is negative, it's actually in this line here and this line here. But to work out what these acute angles are in there, you still have to work out what this one is here. Once you work out that one, we know that this one here is 60, this one here is 60, this one becomes 120, and this one becomes, got a plus 60 to 180, so 240. Okay. Now the reason I'm bringing this up is because if we were then to write the answer for that one, we would not include the 60, because we want when is cos of x equal to a negative a half. And it's not equal to negative a half at 60 degrees. It's equal to a half at 60 degrees, but it's equal to negative a half at 120 and 240 degrees. Okay. However, this question was asking us for the negative 1/2, so we only put in the negative 1/2. It was asking us for the positive half, so we only need to solve for the positive half. Okay, so that's how we solve equations. I'll see you guys in the next one where we solve equations involving compound angles.